Assalamualaikum. So in this video we're going to solve past paper questions of topic deformation from the year 2025. Okay, so let's begin with the first question. A student investigate a spring that the variation of the length of the spring with the force applied to the spring is shown. What is the spring constant of the spring? Okay, so we have to apply Hooke's law. We know F is equals to k into x. What you have to find k, so k will be equals to f over x. Okay, so what we can do, we can choose any force on the straight line. I'm going to choose this point. Okay, so at this point the force is 4.2 and you have to check the extension. Okay, so the common mistake is student take 0.6. 0.6 is the final length, it's not the extension. It started from 0.2 and it's moving till 0.6. So the change in length is 0.6 minus 0.2. So it will be 2.4 divided by change in length is basically 0.6 minus 0.2. That will be 2.4 divided by 0.4. This thing will give you 6.0. Okay, so it's option D we have. In the next question, the graph shows the variation with the force of extension of a wire, and the graph is shown. The force is gradually increased to maximum at Q. So this is showing the force is increasing and it's reaching point Q and gradually decrease to 0 at R. So when the force is decreased, this thing is going back and it's reached the R. Which statement is correct? Okay, if you first try to understand this graph, what this is showing, it is started from 0 extension. It's moving all the way to some extension at point Q, but when you remove the load, this thing is going back to the original thing. So from where it started, it reached back to the same thing. So this thing is called elastic deformation. Okay, when object go back to the original shape, this is elastic deformation. Why? Because it's going back to the original shape. Okay, extension will be 0 when you remove the load. So now you have to choose the option. Along the line PQ, the wire obeys Hooke's law. No, Hooke's law is only applicable on the straight line when there is a limit of proportionality. Along the line RP, yes, RP, the spring constant is equals to extension and force. Okay, RP is even a straight line. It looks, yes, it's a straight line, but it's not equals to extension over 4. K is equals to force over extension. Okay, the wire has elastic deformation. Yes, it is elastic deformation. Okay, and let's see the D part as well. The work done in stretching the wire to P is equals to force into extension. No, work done is basically it's equals to area under graph. And for limit of proportionality, the area in the graph, it will be mostly 1 by 2 base into height. Okay, so it can be 1 by 2 f into 1 by 2 f into x. It will be, it's not the option. Okay, so option C is correct. And the next question, a uniform metal wire of length L and diameter D has a spring constant K. What is the Young modulus of the metal? Okay, so you have to find the Young modulus. So you have to derive your relation in form of this, in form of K, L and D. So what we know Young modulus Y is stress over strain. Stress is force over area. Strain is change over length over original length. It can be written as F, L will go upside and it will be A into X. Okay, if you see in the options, we have to introduce K. So we know from the Hooke's law, K is equals to F over X. So if you see this thing, this is F, this is X. So you can put F over X is equals to K. So it will be KL over A. Okay, let's see, there is no A in the option as well, so we have to change area as well. wire is always in the circular form. So area of a circle is pi r square, but if you look at the option, there is no r. So you have to convert this thing into the diameter. We know r is equals to d by 2, so it will be pi d squared divided by 4. So you have to put the value of a, so it will give you 4kl over pi d square. So that is option D you have. Okay. Okay, so next question, a student has a copper wire and a steel wire with a length, equal length and cross section. So lengths are same, cross sectional areas are same. The student hangs identical loads, so forces are same. The extension of the two wires are different, so X is not same. X is different for both the wires. The student calculate the stress and strain and Young modulus of the wire, which to identify with the tick that calculated have the equal value. So you need to know the formulas for this thing. Stress, we know it is force over area. Okay, so if you see the given data, F is same, A is same, so stress is same. So for all of them, stress will be same. Okay, for both of them basically. So we have to choose between option A and option D. B and C will not be the option. So let's look at the strain. Strain is basically change in length over original length. Change in length is not same. If change in length is not same, strain will also be not same. Okay, so okay, still we have to look into the Young modulus. Young modulus is stress over strain, and we have looked, stress is same but strain is not same, so Young modulus will also not be same, it will be different. So we are, it's option A, only stress will be same, strain and Young modulus will be different for that thing. Okay, the next question, two springs X and Y stretch elastically. The graph shows the variation with the extension X of the force F applied to the spring. Okay, which statement is correct? So what statements we have? Which statement is correct? When each spring is given the same extension, the energy is 4 times the energy of stored in X. And okay, so there are different conditions. This is for the same extension condition. This is also for the same extension. Okay, and when the same force, and the C and D option is talking about same forces. Okay, so let's look at this. You have to compare the energies of both X and Y. Okay, so let's try to sort out, can we choose option A or B or not. So for same extension, so let's choose X is equals to 5. So spring X, and let's solve here for spring Y. Okay, so spring X, if you see at extension 10, force is 20. So extension 5, the force will be 10. Both are directly proportional, right? So if you half the extension, the force will be half. So you have to find the energy. Energy, we know the relation, it is equals to E is 1 over 2 F into X. Okay, so E is equals to 1 by 2, F is 10, X is 5. That will give you 25. I'm not converting the units, although you have to convert it if you have to convert, if you have to give the answer in joules. Okay, but we just have to compare it, so there is no need to convert them. Okay, so for Y, E is equals to 1 over 2 force into extension. Force is 80, extension is 5. That will give me 200. Okay, so energy in Y is 200, energy in X is 25. So let's see what is the comparison. 200 divided by 25 will give you 8. Its mean energy in Y is 8 times. Okay, 8 times more. So look at the option. When each spring is given the same extension, the energy stored in Y is 8 times the energy stored in X. Okay, so this is the right option. So we don't have to check for C and D. You can check it if you want to. What you have to do, you have to keep the same force and then you have to do all the calculation. So what you can do, you can, let's suppose, take the force 20 and this is 10, and for this the force, when it will be 20, the extension will be, as force is 4 times less, the extension should also be 4 times less. It will be 5 by 4 extension. So you can do the calculation for this thing as well, and you can check C and D will not be correct. Okay. In the next question, which phrase describes the strain at the elastic limit on a stress strain graph? Okay, so for this question, the maximum strain below which the Hooke's law is obeyed. No, Hooke's law, if you remember the graphs, for any stress strain graph or force extension graph, first you get the straight line, then this line will be curved. Okay, this straight line is showing limit of proportionality. Hooke's law is applicable here. You can apply Hooke's law. Achha, this thing might be at some point here, there will be a elastic limit. This elastic limit is showing beyond this point the object will not go back to the original shape. It does not show that till this point you can apply the Hooke's law. Okay, so this statement is wrong. That is why Hooke's law is applicable till the limit of proportionality, not the elastic limit. Okay, then in part B, the maximum strain below which the deformation is plastic, not below it is plastic, below it is elastic. Okay, after the elastic limit the deformation will be the plastic deformation. So this is not the option. Okay, the minimum strain, no, and the minimum strain above which the deformation will be plastic, yes. If you go above the elastic limit, the deformation will be permanent. That is called the plastic deformation. In the next question, what are the units of stress, strain and Young modulus? Okay, so we know stress is force over area, same as the pressure, so it is Pascal. For strain, it is change over length, change in length over original length. So this is meter, this is meter, they will cancel out, no units. Okay, and for Young modulus, it is stress over strain, so it is Pascal over 1 is Pascal. Okay, so it is option D, that is the right one. Okay, in the next question, the force extension graph for a metal wire is shown. Which quantity is represented by the area under the graph? It's pretty simple, it is work done on the wire. Okay, in the next question, a wire of length L0 is attached at one end to the fixed point. A tensile force is applied to the other end so that the wire extended length is L1. What is the strain in the wire? So you need to know the formula for the strain. Strain is change in length over original length. Original length is given, this is L0, and X is change in length, that will be final length minus initial length. So it can be written as L1 minus L0 over L0. Okay, most students ask, why sir you are putting this thing? Because if you see the options, there is no X in the options, right? So you have to convert this into the form of L1 and L0 in which the options are given. Okay, so this L0 is divided with both of them, so you can write them like this individually. This will be cancelled out, so it will be written as L over L0 minus 1. It is option A. In the next question, a wire of length L is stretched to determine its limit of proportionality. The graph shows the variation of extension X with the force applied to the wire. Okay, this is the graph that is given actually. The limit of proportionality is given by point P on the graph. Okay, you have the experiment is repeated with another wire of length 2L, but the same material. Material is same, you're just increasing the length, and diameter or area is also same. Which point on the graph shows the limit of proportionality? What you just have to keep in mind, if length of wire is increased by keeping all other parameters constant, like the material and the area, etc., okay, then you can say spring constant, sorry, it's not spring constant, force required to stretch the wire will decrease. You need less force to stretch the wire. Okay, so if you see, if this graph is going towards the C option, it is showing you need more force to stretch this thing. If this is going towards the B option, it is showing the same pattern. It's mean the nothing is changing, same force applied to make the same extension as it was previously. But D is showing, what D is showing, if you see at point D, you need less force or almost equal force as A, but extension is more. So less force is producing more extension when the length is increased. So this is the correct option. Okay, this one is the correct option, D. What is the definition of strain? Okay, so strain is basically change in length over original length. So it's a pretty simple question. It's option B. In the next question, a spring of unstretched length 0.1 meter is suspended vertically from a support. A weight of 2 Newton is attached with it. Okay, what we have length, we have weight, and it increased its, so let's call this thing L0, initial length, this is the final length, this is the force. Okay, then what you have done, you have increased the force. There is another scenario, additional weight of 4 Newton is added, and it is obeying the Hooke's law. How much extra elastic energy is stored in it when the additional weight of 4 Newton is added? Okay, so you have to find additional elastic energy. Okay, so what we know, elastic energy is equals to half 1 by 2 F into X, or you can say 1 by 2 kx square. Okay, you can solve it by both method. I will prefer F into X because we have F and we have X as well. So let's call this one the first one, this condition that we have. Okay, let's call this the first case. I'm finding the elastic energy for this thing. It is 1 by 2, force I have is 2, and extension is 0.15 minus 0.10. Okay, so this will give you, this 2 will cancel out, 0.15 minus this will be 0.05 joules. Okay, so this is the initial energy. Finally, you are adding 4 Newton. Adding 4 Newton to what already there was 2 Newton force. So F will be, in that case, 2 plus 4, that is 6 Newton. Okay, you can solve it by finding the spring constant, but you can do it directly as well. As if you see, the initially force was 2, the force was 2, now the force is 6, 3 times increased. Initially the extension was, this is the extension, right, 0.05. what the extension will be now, you can find with the ratio method. Okay, so X will be equals to 0.05 into 6 divided by 2. Okay, so it will be 3 times 0.05, or you can simply say as the force is increased 3 times, the extension will also be increased 3 times. So this thing will give you 3 into 0.05 is 0.15 if I'm not wrong. Okay, so you can find the energy is, this is x and this is f, both you have. So E2 is 1 by 2 f into x, it is 1 by 2, f is 6, x is 0.15. So this thing will give you 0.45 joules. What you have to find, extra elastic energy. So you have to find E2 minus E1. E2 is 0.45 and E1 is 0.05. That will give you 0.40. That's option D you have. Okay. In the next question, a wire is extended by a tensile force so that the deformation is elastic. What is meant by the elastic deformation? Okay, it's option D. When you remove the force, the wire will go back to its original length. That is called elastic deformation. Okay, in the next question, a bolt is subjected to a tensile force as shown in the diagram. The bolt has a circular cross section. Okay, there are two ends. One is the end X, one is the end Y. You have to find the ratio of stress. Forces will be same. Okay, so stress is basically, we can write as F over area of Y, and this is F over area of X. Okay, this F will be cancelled out, this X will go up, so it will give you area of X divided by area of Y. Okay, and we know that you have the diameter, so we know area is pi d square divided by 4. So for X it will be pi, X diameter is 2d. Okay, so it is 2d square divided by 4, and for area of Y it is pi d square divided by 4. So this pi, this 4, this 4 will be cancelled out. It will give you 4d square divided by d square. So this will cancel out. It will be 4. Okay, so it is option